Hello everyone. Today we will have an online lecture and I want to announce the following things. Homework 5 will be posted on the Foxtail and there is no class, no lab in the classroom on Thursday, but you will have an online lecture, so you need to watch this video. And second, there is first midterm exam in the classroom on February 11, Thursdays. So it will cover chapter 1, chapter 2, and some part of chapter 3. I will allow you to have one equation sheet and calculator, so you can bring the calculator. I will post study guideline on the Foxtail. Okay, now let's move to the lecture. So today we will talk about the Thevenin and Norton equivalent circuits. So here this is kinds of source circuit. Now one question I brought it. If you are interested in only the output signal from the original circuits, can we simplify it? If yes, then how can we make equivalent circuits? That's the questions. And we need to answer for the question through this lecture today. Now one circuit is kind of a little complicated circuit. So this circuit was given and there is two end. There is two terminal. One is the A terminal and the other one is B terminal from the circuit. And from the A circuit and B circuit, signal coming out. This signal can be current wave or voltage wave, either one of them. But important thing is that this original circuit has very complicated interconnection with electrical elements, resistors, dependent voltage source, resistor, current source, and the resistor, something like that. These connections, this circuit is not simple, complicated. Somehow those signals come out of A and B terminals. So we are interested in only these signals only. We don't care in internal connection in these circuits. Then now, so can we make a simplified? Yes, right? Then what kinds of how can we make a simplification of the circuit? One way is that we need signal source. One is voltage source or current source. And the other one is that in order to control current source amount, we need resistance. So one source and one resistance essentials. How about this? One voltage source and resistance. How about one current source and one resistance? They are in parallel and they are in series. Yeah, one of them. So they are equivalent. What do you think? Those are equivalent or not? Yes, it should be equivalent. So we can replace this original circuit with equivalent circuit, Norton or Thevenin equivalent. So here, one source, one voltage source, and one resistance connection. This circuit, we call it Thevenin equivalent circuit. If current source connected with resistance in parallel, that circuit is Norton equivalent circuit. So now look at this. So either we can create Thevenin equivalent circuit or Norton equivalent circuit. This original circuit, take a look at it. So there is two output, two terminals can be connected to the other circuit, and this device can send the signals. So which means that same thing in here, they generate the signals, 1 volt peak-to-peak signals coming out from the A or B terminals. And here also same thing, A terminal and B terminals, and through this circuit, this 1 volt peak-to-peak signals source generate it and send it. So eventually same signal will coming out, 1 volt peak to peak. Or this signal is coming out like a current source, like 1 milliamp current source coming out from the 2 terminal, then that one is kind of 1 milliamp peak to peak signal coming out, same thing. So here we can generate a current source, 1 milliamp source coming out from 2 terminal. So 1 milliamp peak to peak sinusoidal wave signal can come up from the circuit. So those are all equivalent. Now before that, previous I talked about the source. There is 2 types of source. One is current source and the other one is voltage source. One current source or voltage source is the dependent source, and the other one is independent source. Independent source, there is source like voltage or current source. And now here in this case, I brought one example, that is the battery source in the class before. So now here is battery source. Let's assume this one is 1.5 volts AA battery source. Now it's positive and the other one is negative, and they generate the voltage. Positive charge collected to the positive areas and negative charge collected to negative areas, and they create the voltage difference. And however, there is some resistance in the battery. So this resistance in the battery, usually they go to 0 ideally, but in reality it's not the 0. Somehow there is voltage, there is current in the inside of the battery, and one end this is open terminals and the other end also open terminals. These 2 open terminals can be connected to the other circuit and supply the charge. So here voltage source, take a look at it. This one is kind of 1 voltage source and 1 resistance. Which means kind of the Thevenin equivalent circuit, right? Exactly. Or let's assume this voltage or this battery if this battery is the current source, so now positive charge and the negative charge, and then they flow it, so they connect it to inside this charge, they flow it. And this one is connected to the other, so they connected each other. They is in a loop. So positive charge, they can circulate it in the battery. When this 2 terminal, positive and negative, connected to the other circuits, then this current, this charge starts flow through the circuit. So in this current circuit, one current source connected with the resistance in parallel. So this is the current source, and that one is voltage source. This is current source. We learned before. Likewise, original circuit. This original circuit, we don't know what happened in the inside of the circuit, but they generate the signal from the 2 terminal open circuits. So this is kind of signal source, current source or voltage source. That's why we want to make a equivalent circuit. This circuit can be replaced by one of them, the Thevenin equivalent circuit or by Norton equivalent circuits. Okay. Here, one more original circuit consists of several resistance or source, but we are only interested in the output signal from the circuits, like that. So we don't care inside of the circuit connections, interconnection, we don't care. So we don't need to draw all the circuit because it's not necessary to know. So in this case, we can simplify it, or we can replace this device by the Thevenin equivalent circuit. Important thing is that in order to make a simple equivalent circuit, you need one source, one signal source, and one resistance to control the signals, at least. Okay. Here, then I brought one example of the Thevenin or Norton equivalent circuits here. So now left part, take a look at it. One signal source, current or voltage source that is connected with the resistance in series. And there is two open terminals. These two open terminals connected to the amplifier, and then amplifier inside interconnections, like a lot of circuits in the inside. We don't know in detail, but somehow amplify input signal to the other signals, transform other signals. So output signals, they generated from the two terminals of our amplifier. So now example, like input 1 volt peak to peak input signals can be transformed into, like example, 10 volts peak to peak output signals through the amplifier. So here, those things, the Thevenin equivalent circuit, you can use it. Okay.